Welcome to my classroom. In this model number 4, we have started with batteries, and in that we have focused on its end use, where we are going to make use in transport sector, that is e-vehicles, right? So in that we have discussed about what are different type of vehicles possible with the e-vehicles, whether it is purely e-vehicle or it is hybrid vehicle or it is ICE engine vehicle or not, and what is the comparisons have been discussed in the previous lecture. Now we will, in this lecture we will discuss in detail about this, what is the overview of these electric vehicles in India, what is the intended plan of the government. Okay, so what is the vehicle dynamics in our society, particularly our Indian market, whether it is a two-wheeler driven market or three-wheeler or four-wheeler or public transport is more or that, like that, because each country has its own dynamism on what type of two-wheeler means vehicle is being preferred by the consumers. Actually, consumers are the one who decides what needs to be supplied, right? So we will discuss this in the Indian context. If you look at the Indian scenario, where how we should move towards the e-vehicles than the ICE based vehicles, and if you look at the most polluted 50 cities in the world, data released in 2022, you can see that most of the cities in India, around 30 to 35 cities are from India, which lists in top 50 most polluted cities in the world, which is a shame for all of us, right? So you can see that many cities, Ghaziabad, Delhi, Noida, okay, Baghdad, Hisar, Faridabad, Greater Noida, Rohtak, Jind, Lucknow, Varanasi, Kanpur. Okay, so you have Meerut. These are top 25, and if 26 to 50 also, you can see so many Indian cities like Patna, Durgapur, Agra, Yamunanagar, Muzaffarnagar, Sonipat. You can see even Singrauli, Jodhpur. So all across India, we have several cities which are most polluted in the world. Okay, so and most of this pollution, and if you look at around 36 percentage of this NOx emissions are due to 36 percentage of NOx emissions are due to vehicles. Okay, and if you look at the 20 percentage of particulate matter 2.5 emission in Delhi is also mainly due to vehicles. That is also IC engine based, that is internal combustion engine based vehicles. Okay, so that is in such scenario, if there is a pressing need to reduce the CO2 or NOx emissions in the air to avoid the air pollution. If we want to reduce the pollutant, dangerous pollutant level have been crossed in several cities. If we want to address this air pollution issue, we need to shift from IC engine to electric vehicles, which we have discussed earlier also. Okay, and another issue with respect to economy point of view, we have discussed in the previous lecture. Also, if you want some data also, if you see that in 1981, India was actually India was around importing 168 billion 160 billion rupees we have been importing. Okay, so the crude oil imported was of worth 168 billion rupees. Okay, but in 2015, if you look at the same figure, it is around 6,538 billion rupees. Okay, so that means that there is a increase of 40x times. Okay, that is 40 times our import bill on petroleum products, either it may be in the form of crude. Okay, so including all forms of petroleum products, our import bill has increased at least 40 times in past decade. Okay, 1981 to 2015, there is significant increase there. You can see that 50x times. Okay, and if you look at the advantage point of view, these are some of the driving forces why we have to shift from EVs and why there is increasing interest towards e-vehicles. Okay, and if you look at the efficiency point of view with comparison to ICE vehicles, are this is EVs are at least 4 times. These vehicles are 4 times energy efficient than the ICE vehicles. Okay, and also if you look at the number of moving parts, and in terms of number of moving parts, it is 50 times less. Okay, 50 times less moving parts are there in the e-vehicles. So these are some of the reasons why we have to move towards the e-vehicles from the ICE based vehicles. Okay, but in all these e-vehicles, see, e-vehicle can be, if it is purely e-vehicle, we have seen that it is mainly based on battery usage, right? So battery is an important part, integral part in these e-vehicles, which is used for energy storage. Okay, for energy storage, battery is being used. And if you look at the what type of battery is used, and what is the problem, where is the problem from switching from ICE engines to this electric vehicle, is mainly based on the availability of battery at the affordable cost. Because what type of battery is there, it based on the weight, what is the weight of the battery, or what is the volume or the space it is occupying, and what is the cost, right? And all these are interrelated, right? And based on the weight and the size, based on the weight and size, we are going to have energy density. Okay, so this energy density can be either gravimetric or as well as volumetric, right? We may have gravimetric energy density or volumetric energy density. Okay, and if for example a 30-watt bulb, when you are using a bulb, okay, a 30-watt bulb, if you have a 30-watt bulb, it can be used for 1 hour and it will consume 30 watt hour of energy. Okay, that's why we are telling what is watt hour. That is the unit of energy. Okay, so the unit of energy is watt hour. For example, we used to tell that 1 watt of power for 1 hour means, so that is 1 watt hour. That is the unit of energy. For example, a 30-watt bulb used for 1 hour will consume 30 watt hour of energy. And the unit of energy used for electrical metering at our home is in kilowatt hours, right? It our how many units it consumed in your house, because the billing in our state, each state have a different billing, right? Up to 100 units free, 100 to 150 is a different price, 200 to 500 another price. If it is crossing 700, there is another margin. Okay, so for poor people, they give it affordable price of 6 rupees per unit, right? Some after that it may be 10 rupees, 12 rupees, 15 rupees for industrial purpose, some other price. So like that, it varies with a different state, right? Because it is under state government. Okay, so each state government fixes the EB bill, right? The cost for EB bill, electricity bill, varies at different places. But we used to know that, note that what, how much kilowatt hour is being consumed in our home, right? So that is the unit of energy used for electrical metering, that we know that. And 1000 watt used for 1 hour, 1000 watt used for 1 hour, or 100 watt used for 10 hours. Okay, or you can even you can say that if you look at any small Indian home, we will be considering consuming at least 2 units. So 1 kilowatt hour is the 1 unit. Okay, so 1 kilowatt hour is equal to 1 unit. Let me say, on an average, any household, middle class, or you can say small Indian household, will be consuming 2 units of electricity per day. Okay, so that is the electricity consumption, and in 30 days we will be getting 60 units. Okay, and 60 into 10 rupees, 600 rupees, you will be getting EB bill. Okay, and if you look at what is gravitational energy density and volumetric energy density, it is the watt hour per kg is based on gravitational. Okay, so gravimetric energy density is the per kg. Okay, that means how much watt hour per kg you will be able to get. So for example, you have a we say no weight of the battery, volume of the battery, and cost of the battery. So per kg of the battery, how much whatever you will able to get. That is gravimetric energy density. And what is volumetric energy density? It is based on the volume. That means what will be the denominator here? It is the watt hour per liters of the. So it can be for any fuel. You can tell that even for battery it is applicable. Okay. So how much energy we can store in an electrical battery, or how much we can store in a fuel cell? So we can always, we are going to compare our fuel cell with batteries. Okay, so how much you can compare? You can see that it can be, you can for any fuel. For any fuel, you can, as a homework, you can prepare a table for petrol. What is the energy density? For coal, what is the energy density? For wood, what is the energy density? Okay, so you can compare the values for it. Okay, please do that. And if you come to one of the major type of like batteries, we are going to discuss in detail about batteries separately. And if you compare to these lithium ion batteries, if you look at lithium ion batteries, its energy density is ever increasing. That is why we are able to commercialize the e-vehicles in the latest 5-10 years. Okay, because this gravimetric energy density, if you say GED, which is gravimetric energy density of your cells, it is ranging from 250 to 300 watt hour per kg, because denominator is kg when you say gravimetric energy density. Okay, so that is what we are able to achieve as of today. Okay, and the goal is to reach about 400 to 500 watt hour per kg in the coming years. That is a goal of who is funding the research of these areas. The giant vehicle manufacturers like Toyota or Volkswagen, Maruti, all these people fund the research in these areas to improve the gravimetric energy density of the batteries, particularly lithium ion batteries. Currently we are able to achieve 300, means we want to have it around 500 watt hour per kg. Okay, so we want to have other types of lithium batteries may even emerge to drive the energy density higher. Okay, so currently lithium ion batteries have achieved this. So any modifications or research can be carried out. Okay, so that is where Tata Motors also hiring some of our MTech students as interns, and they will be working on batteries. I was told by one of the students who got selected. Okay, so that is the objective. Whatever improvement we want to do in the research and development, that is going to help our total society. Okay, so overall, it's going to help our economy. It is going to help our ecosystem. It is going to help the end use customer, because his monthly expenses towards petrol can be reduced, right? So that is the importance of research and development in any research areas. Particularly, our chemical engineers going to focus on these batteries. Okay. Remember, not only chemical engineers, it is from people from chemistry, people from metallurgy. They all also will come to work in this area. Okay. So what is the meaning of this? Higher the energy density, we are going to have some higher safety concerns also, right? Because we know that cost of the battery is inversely proportional to energy density. If you look at the cost is inversely proportional to energy density. Inversely proportional, right? It's not directly proportional. So inversely proportional. If the denominator is increasing, what will happen? You know that. Okay. So how we can have high energy density materials? What we are going to use is, we want to reduce the materials that are being used in the one. Okay, so we want to use lower use of the materials like lithium, cobalt. We want to nickel, manganese, graphite. Okay, And how we can reduce the, what is the increase in the energy density? If you look at, you can see that with years, how we are able to reduce the battery price. Okay. So in 2011, if you look at 2015, you can see 2018 and 2020. What has happened is, if you look at the energy density, okay, that is in gravimetric energy density. What is the unit? Watt hour per kg. In 2011, it was only 80 was able to achieve. In 20, we have able to achieve around 310, which is keep on increasing. So what has happened to the cell price is, it was around $800, then it has came down to $110. Okay. So the more we are able to increase the energy density, we are able to bring down the cost drastically. Okay. So that is where it is feasible to make commercialization of e-vehicles. Okay. So the commercialization of e-vehicles was thanks to the increase in the gravimetric energy density, so which is an outcome of the research work carried out by the people working in battery areas. Okay. And you can even compute the, what is the cost per kilowatt hour of usage. Okay. Because there is a cost of storing the kilowatt hour of energy, then we are drawing it. Because in what is the battery we are doing? First we are charging it and it is discharging, right? So it is going through a charging and discharging, right? So there is a cost involved to it, right? What is the cost per kilowatt hour of usage of battery? Hmm? So how many times we can use, that also important. So how many times the storage be used? That is called as number of cycles. Because if it is a rechargeable battery, number of cycles that a battery can perform, right? That is also important, right? Because you bought a new mobile phone, you do daily basis. Some people use it if you are single and you don't use much of games, all that. If you charge it today, 3 days you can use. So 3 days once you will be charging. Per month, how many times you will be charging? Per year, how many times you will charging? That determines the life of your battery, right? How many cycles you are doing, right? Full charge, full discharge, full charge, full discharge, right? So like that, how many times we can do, that is called as number of cycles. Okay. So what will happen if the size of the storage reduces and one keep recycling, or sorry, keeps cycling these things. Okay. So that also will contribute. Also, what we have to consider is, what is the capital cost of the battery and what is its depreciation cost. Okay. We have to consider the depreciation cost. We have to consider the interest on the capital, right? So we have capital cost, we have interest cost is there, right? So depreciation cost, what is the interest we are paying on this capital cost? So all that needs to be, and what is the operational cost? This is applicable for any material investment, right? With respect to design point of view or investment point of view, it's important. Okay. So these all depends on the lifetime of usage to compute the effective depreciation on there. Because when you want to know the depreciation cost, interest and operational cost, you should know how many years a battery will come, right? Because initial year, number of years is important, right? Number of years you can use any product is important. So same way, if for any product, when you want to calculate the depreciation, we will be, so we will be making using the calculate means number of years. For example, I bought a bike. Okay. So we bought a bike and its life cycle is 10 years. I bought it for 1 lakh, right? And end it is scrap value is around 2000. So I can calculate the what is the per year divide by the year, all that, and consider depreciation, all that. You'll come to know what is the depreciation cost, interest cost, all that. Okay. Now, with respect to battery capital cost, it is around 12K. It is around 12,000. See, inverter battery, if you want to buy it for house, okay. So we are buying it almost for 12,000 to 15,000. Okay. So per kilowatt hour. For not so small battery, higher for small battery. Okay. So this is the amount that we are spending on the batteries. Okay, so we want to reduce this cost. Okay, so not everybody is able to afford an inverter at our home, right? So if you somebody want to afford, if the price is further reduced to 2,000 or 5,000 rupees per kilowatt hour, everybody will able to have an inverter battery at home, right? So that is a power backup at our home. Okay, that is one such application. Okay, so but if you look at road transport, all that we are going to discuss in detail. And coming to the Indian market, Indian vehicle market, or you can say which type of vehicles are dominating in the market. You can see that we can classify these vehicles as passenger vehicles or public transport vehicles, right? So passenger type of vehicle, buses or vans. Okay, so there are such type of vehicles. So passenger vehicles are there, and we have commercial vehicles, commercial trucks are there, right? And then the commercial vehicle refers to the transport, big transport vehicles. Okay, these passenger transport vehicles and commercial commodity transport vehicles are there. Then comes our three wheelers. Three wheelers are like autos, like three wheelers are there. Then comes two wheelers. Okay, and what is the proportion you think in India? What which vehicle is more? What is the composition of that? If you look at the number of vehicles in millions, I'll just compare the values of 2017, 18, and 2018. In these 2 years, what has happened? Okay, so if you look at these 2 years, the number of vehicles, it's like number of millions of vehicles that is being sold, because that is how we come to know the market, right? Number of vehicles sold in India. Number of vehicles sold, because this is as per data, na? Because all are paying tax, so they know how many vehicles sold out. Okay, so if you look at these vehicles, if you look at transport vehicle, the number is 3.29 millions, and it has risen to 3.38 millions. So that is the increase in these 2 years. And if you look at commercial vehicle, it was around 0.86 millions, which has rose to 1.01 million. And if you look at number of three wheelers, it has increased from 0.64 million to 0.7 millions. And if you look at two wheelers, it has increased from 20.2 million to 21.18 million. So it means that totally we are having around 24.98 million vehicles on road, different type of vehicles, which has increased to 26.27 million in 2018. Okay, so now you can collect data for 2021-22, what is being done, because once we have a data available, we can update our database with it. Okay, so it is always increasing, because ever increasing, right? Because nowadays even people have to wait after booking the passenger vehicles like car. Okay, nowadays even you can see that people moving from IC engine to green board vehicles. What is green board vehicles? It may be running on purely electric vehicle or hybrid, or it may be based on fuel cell vehicles. Okay, so we get green board for that. And if you look at this, among the total vehicles, it is 14% of the overall vehicle is around cars. Okay, so that way, even we have premium cars with more than even 1 million rupees. Okay. And with respect to these vehicles, what is the affordability? What is the percentage of, I told the cars percentage is 14 percentage. And what is the percentage of this two wheeler? Okay, so what is, you can see the dominant in millions, 20 million compared to passenger vehicle 3.2 or 0.86, which means that around 80 percentage of the vehicles being sold are two wheelers. Okay, 80 percentage, you can say exactly 79 percentage. Okay, so that way, and also if you include the autos, including small good vehicle like Tata Ace or Ape kind of vehicle. Okay, so small goods vehicle if you include, so they are also coming into picture. And if you look at the economic cars, that is the basic model cars, which is below 1 million rupees. So that is around 12%. Okay. Autos are around 4%. So around 95% of the vehicles are based on two-wheelers, based on autos, or based on economic cars. That is low-end cars, like starting models. Okay. So that way 95% is there. So that is where India's auto segment is different from the other countries. Okay. So we want something which is small and affordable vehicles. So that's where even nano vehicle was introduced by Tata. Even now means they could able to reflect on the failure of nano car is in India. If you have car, it is not, it is a status symbol. So when they introduced it in the name of India's cheapest car, when they use the word cheapest, it didn't reach out well to the market, and that is one of the reason. In actually, it was presented in IMBA presentation where they told that they should have introduced or marketed that vehicle as most affordable car. See, name matters. Okay, most affordable car. If they marketed in this name, it could have been a grand success. That is where it is from their own reflection. Okay, so instead of that, what they did, they introduced as most cheapest car in the world, or something like that. So that has flopped. Okay, so that's where in management in nowadays they focus on how to advertise, how to promote your things also. Okay, because it is not going to suit all type of markets. Okay, so in India we have different type of complexion. Okay, so that way in India we should have some different strategy also, right? So we should have a proper strategy in India. Okay, so if you look at India's electric vehicle strategy, how to move to, because ours is, as we said, we want to have a cheap, low cost and easily affordable vehicles only we want, right? So that way we have to introduce such vehicles first, because 95% of market you are seeing that it is based on your two-wheelers or autos. Okay, so what happened, we should focus on these vehicles most. Okay, so because only less percentage of cars are only being used, so primarily instead of focusing on car as a first step, we have been focusing on introducing e-vehicles, two-wheelers. That is where more 90% people are focusing, and introducing such autos or economic cars. So that is where we have to, because that is the number of units which is being sold in large number, right? So that we have to focus, right? So that way, that because that is the one which is being there, right? So the price point in India is much lower than in the Western countries, which is mainly driven by the affordability. As I told, affordable cars. I am not using cheapest car. It is affordable for larger section of people. See, Rima, India is a peculiar place where you can survive a day, because such wide range of economy ours is. We are able to sustain. You can see that a person can survive with 100 rupees, a person can survive with 1,000, a person can survive with 1 lakh. India has everything available for such people also. Per day, if you are earning only 1,000, somebody is able to earn only 500. Okay, so they are able to get food. Say for example, one can get its breakfast for 20 rupees, and he can even get for 2,000 rupees. We can get for 200 rupees. We can get for 100 rupees. So each range, people according to their own thinking and their own status and their own affordability, one can survive in this country. Similarly, one can travel from one place to another place with just 500 rupees, and somebody can travel with 5,000, somebody can travel with 50,000. That is, a person with 500 will be moving on road. Somebody who can afford 5,000 will go travel by thing. Even in our train also, we have different coaches, right? With 500 rupees, one can go drive in an unreserved coach. Somebody can go in sleeper coach with 1,000. Somebody can travel with 3,000 in third AC, 5,000 in second AC, 6,000 in AC, or somebody can afford Rajdhani with ever-changing prices. We can travel, right? So India is such a diverse country where a person is able to survive with a different economy. Okay, so that is where even during this lockdown we are able to survive. And when people who couldn't afford then large section of people came forward to donate and they helped them to feed, right? During winter, governments are providing shelter. They convert the bus depots or buses or non-running vehicles into a temporary shelter, and they are able to make them live, survive the winter like that, right? So that is where for each section of people, our governments are able to work. Okay, the moment they decide to help. Okay, and if you look at the premium four-wheelers, it's only 2% in India. So when we say premium, these are high-end cars. Okay, so premium cars, or you can say any Jeep also. Okay, so any four-wheelers, it is only 2% in the Indian market, and it is similar to that in the rest of the world. So what India could learn and adopt is it can encourage the multinationals to manufacture their premium cars in India. It will help us to build a strong ecosystem for their components and subsystem. It's hey, if you go to Jamshedpur, or if you have Tata Motors, it's not that one company is there. Based on that, to supply a nut bolt, to supply a gear, so to supply some circuit. So there are around 2,000 to 5,000 small scale units are there. It is like they were not directly related to Tata. What they do is they sub suppliers are there. So they give tender to somebody, that fellow gives sub tender like that. So if you look at the streets in the Jamshedpur away from the city, you will see lot of small scale units. Small, it's like a petty shop. It will be there, but they will be keep on making nut, and he will say this nut is being, because it should match all the standards. It should match all the standards specified according to ASTM standard or all safety. So that fellow will keep producing that particular small part, which is finally going to one of the part in the final vehicle that is being made. So that way, this it will help us the ecosystem. It will help the stronger ecosystem. If this fellow closes his company here, so what will happen to these 2,000 employee shops? There are in each shop, we assume 10 people are working, so you are providing opportunity, job opportunity. Okay, so that's why government encourages people to start a company. Means this go not direct employment. There may be 100 people working in that campus, but indirect employment is being also provided in that one. Okay, so that is why government gives some subsidy, free land, all that, but it is being even misused also. Okay, and if you look at the role of battery, coming back to batteries, if you have an e-vehicle and you have an ICE vehicle, okay, so EV vehicles without battery will cost less than the IC vehicles if there is no battery is in there. But the moment you add battery to it, its cost is going to be greater than this IC engine. Okay, because battery is an extra cost in these electric vehicles, and it is the most dominant cost in the electric vehicles. Okay, so the battery cost is more dominant. Okay, because in ICE requires a low cost petrol tank to store the fuel. Because if you look at the store fuel part, it is going to have a petrol tank. That's all right. It is a low cost petrol tank just to store the energy, that is to keep the fuel in it, right? Whereas if you coming to the fuel part of the electric vehicle, that is going to be the costliest part, which is the battery. So that is where, in comparison to EV and ICE, these two difference coming into picture. The cost is little higher in the electric vehicle in the capital cost in comparison to ICE cost. That's why I think even in the last lecture I showed you the cost of ICE vehicle is this and the cost of EV vehicle is this. What government does is government posts some several taxes and gives very less tax. So what happens to the total cost? The total cost of electric vehicle means EV vehicles is less than the IC vehicles. So that is where the consumer is interested to buy electric vehicles than the IC vehicles. Okay. Also, the government is keep on increasing the fuel prices. Operation, it is capital cost, right? And if you look at the operational cost, government keep on increasing the petrol prices. Okay, even when the dollar of crude oil is being decreasing, we keep the petrol prices high, which means that somebody if is not able to afford that will shift towards these EV vehicles, which we have discussed in detail in the previous lecture, right? And this EVs without battery will cost less than an equivalent IC vehicle, as I told you. Okay. And how we can improve the efficiency? How we can improve the efficiency of these electric vehicles? So, because the cost, we know that obviously operational cost is going to be less with respect to batteries, but capital cost is going to be more. So that and all, in long run, if you do some cost analysis only, a consumer will come to know that in 5 years, whatever extra cost that I am investing in EV vehicles will be compensated with by less expense on the operational cost. But uneducated people, it is very difficult to understand. But however, there is we can keep on improving the efficiency by improving the motor or control efficiency. So if you look at the motor or controller efficiency, we'll able to overall efficiency of the electric vehicle can be improved, right? And we can improve the efficiency. We can have a better tires. Remember, when you are using any what type of tire you are using, and whether it is a new tire or old tire, okay, what is its rolling resistance? It should be lower, okay. And even when you make the body part of the vehicle, we know that in the fluid mechanics course you have learned that streamlining is important for the aerodynamics. We want to have streamlining, right? So that and all aerodynamics also needs to be taken care. So if you have a better vehicle aerodynamics, so even for aeroplane also it is same. Okay. If you have better aerodynamics, and it should have low weight. Okay. So if you have better tire, we have better control. We can overall efficiency of the electric vehicle can be increased. Okay. So I was telling you about the cost, operating cost. Actually, if you come to the battery cost will reduce with capacity. Okay. So for example, 18,000 rupees, it can be 18,000 rupees per kilowatt hour. It can be reduced to 13,500 kilowatt hour rupees per hour per kilowatt hour. Okay. So if you are reducing the capacity, battery cost will be reducing. Okay. And if you effective use of battery will be like it can be 85% we can use the into its capacity value. Whatever is the capacity value. Okay. So the effective use of the battery can be only 85% of its capacity. Okay, so this EV operation cost, coming to the operation cost, as the energy efficiency of vehicle increases, say for example, 25 kilowatt hour to 15 kilowatt hour per kilometer, 25 watt hour per kilometer to 15 watt hour per kilometer, one gets higher range of same battery size. Or otherwise, the battery size reduces to a small range, which implies lower capital cost. Okay. For example, you want a vehicle which needs to be operated for 100-kilometer range. So how we can reduce the size with efficiency? We can say that okay. So for example, if it is 25 watt hour per kilometer to 15 watt hour per kilometer is what you get. So battery size for the first case will be 100 into 25 by 0.85 because that is your maximum efficiency possible. So what is going to be 2.9 kilowatt hour. So that should be the battery size for a first set case where you want to have a 25 watt hour per kilometer. Okay. So whereas for 15 kilowatt hour per kilometer, what you have to get? So it is going to be 100 into 100 kilometer is a range. Okay, 100 is a kilometer into this capacity. So 100 into 15 by 0.85. So which makes us 1.8 kilowatt hour. So obviously your battery cost will be less because you don't need a 3 kilowatt hour battery. You need only 1.8 kilowatt hour battery when you want to have this watt hour per kilometer. And what happens in this process? the cost drastically reduces from 43,500 rupees to 30,000 rupees. Okay, so that way the capital cost and the operation cost of the EV batteries is going to change. Okay, well, we will stop here. In the next lecture, we will discuss about the battery cost reduction strategies and business model, wherein we will discuss about how to increase the energy efficiency of the e-vehicles, how to reduce the battery size so that the cost of the battery is reduced, and how we can use split batteries or what is swapping of batteries, and how when you do battery swapping, what are the advantages associated with this, and what are the different approaches that we can use, like a conventional method or a private vehicle method. Okay, and if you use some range extender batteries. Okay, and like if we use a conventional approach, like if you have slow charging normally and fast charging can be done whenever required, and if you provide some infrastructure, how we can improve it, like that. Okay, and we should also look into what are the various factors on which a battery life depends upon, because typically a battery life depends upon the number of cycles, what is a cycle, how many, what is the rate of charging, how the rate of charging affects the battery performance. All that we will discuss in the next lecture. Thank you so much for joining my classroom. Meet you in the next lecture. Bye bye.